Okay, my name is Okulov. Dear participants of the conference, I want to present to your attention a work devoted to the study of the plasma jet properties by creating a computer model of the plasma installation. Plasma method is widely used for coating and powder production processes. In slide show some of the considered design of the plasmatron. This study provides a review of a design of the plasma installation used both for powder production and for coating. As a prototype for creating computer model is a laboratory plasma installation was uploaded, which is used both for powder production and for lining coating. The installation includes a plasmatron, the profile section, cross-section of which is presented in the description in the slide. A number of factors influence the outcome of the powder production and the coating processes. Factors such as temperature of the plasma jet play a special role, very important role. The temperature at each point of plasma jet is different and changes along the axis of the flow and the distance from its core in perpendicular direction. Relate in of the axis jet. Okay. Important task is to define the influence, the parameter of the plasma jet and the final products. The goal of the study is to create an objective model, computer model of the plasma installation to allow an adequately description of the plasma jet flow. The developed mathematical model is planned to be used to predict the parameter of the flow plasma jet affecting for process coating and powder production. To solve the problem, two software package were used, which made it possible evaluate accuracy of the solution. The initial data used in computer modeling are presented on the slide and corresponding to the laboratory plasma installation. Determine the temperature of the characteristic point. Conclude 55 parallel experiments. Based on the result of the study, the histogram was built. As can you see in the slide, the distribution of the random variable obeys the normal Gaussian distribution law. In order to verification the results of the theoretical experiments, a full-scale experiment carried out to establish the temperature in characteristic point. For this, a rod with a diameter of 3 mm made of tungsten was used, which clamped in manipulator. The manipulator was located at the distance of half meter from the plasmatron. Future, the manipulator with the root fixed in the was gradually moved in constant speed of 20 mm per minute, parallel to the axis of the plasma flow toward the plasmatron. The distance from the root to the end point of the anode was recorded. Also, in the full-scale experiment, an optical pyrometer was used, which were used to measure the surface temperature of the free end of the bar. At the moment when the melting process begins on the bar surface, data from pyrometer scale and the distance from bar to the plasmatron were recorded. The parameter of the gas flow rate and its type corresponded to the date used in the empirical experiment. The result of the comparative analysis show satisfactory convergence. The creation model of the laboratory installation is described. They demonstrate what the temperature of the plasma jet flow with the normal Gaussian distribution law. It's confirmed what mathematical model objectively described to the flow of the plasma jet. The results are of practical importance. Thank you for your attention.